Hey everybody, welcome today. If you're coming in, please take a seat. You can sit closer to the front if you want. Today, Max Bélanger and Damien DeVille are going to talk to us about migrating from Python 2 to 3 on Windows, macOS, and Linux. So please give them a round of applause. Welcome them.
Hi, everyone. This is going from 2 to 3 on Windows, macOS, and Linux. My name is Max. I'm an engineer at Dropbox.
Hello, I'm Damien. I'm also an engineer at Dropbox.
All right, so why are we here? Well, the first part of the answer to that question is we love Python. So Dropbox has been using Python actually from the very beginning. The very first lines of code ever written at the company by our CEO, Drew, were actually in Python for Windows. And we use it obviously not just for servers, but also for our desktop clients. We use it on Windows, macOS, and Linux. And that's really just from the beginning all the way to now. We include, in fact, we include our own custom fork of Python that we ship to our users with a whole bunch of fun patches. And really, over the years, we've just become Python fans. We've kind of used it all. We've used async core. We've used multiprocessing. We just love Python. So that's part one. Part two, so for almost a decade, Dropbox has been using Python 2. This actually ended late last year. So in late 2018, we actually made the jump. So we made the leap from Python 2 to 3. And so today, what we want to talk about is the sort of abridged story of our 4-year journey from Python 2 to Python 3. The main takeaway here is that migrating client software has some pretty fun and unique challenges. You may have heard stories of other Python 3 migrations, but we hope ours will be a little bit more interesting because of the crazy things that we've had to do. So without any more delay, let's get to what we're going to talk about today. So we'll start with the why and sort of what led us to finally decide to make the jump. Second, we'll go into the how. So we'll talk about how we laid out the problem that we were facing and how we actually started to solve it. Then we'll do a deep dive into sort of the major efforts that made this project happen. The first one was Project Hercules, where we migrated our entire code base from Python 2 to a hybrid Python 2 and 3 syntax. Then we'll talk about Hydra, which was our hybrid runtime, so the ability to run both 2 and 3 on a user's computer. And then finally, we'll go into how we combine those into actually executing the transition, so how we made the rollout happen. So why would you even want to switch, right? Like, why would you want to make such a giant transition? Isn't Python 2 working just fine? The answer was, it was relatively working just fine. But there were two primary reasons why we wanted to do this, and it was, in a way, a pretty straightforward cost-benefit analysis. So Python 3 had huge benefits that we valued, and Python 2 had huge costs that were becoming difficult to bear. So let's start with Python 3. Python 3 is actually genuinely exciting. It represents the actual evolution of the language, and it shows when you compare the two. So let's start with the GIL. So if you're not familiar, the GIL is this measure that the runtime uses to maintain consistency when you have concurrency with multiple threads, but it does that at the cost of parallelism. The GIL is actually really important in a client-side app because it affects responsiveness. So it affects how quickly your UI can respond to the user's requests. Now, we've been growing the amount of UI that we have in our app, and so Python 3's GIL having all these improvements actually made a difference, and I'll get to why in just a second. Second, native type annotations. So we love type annotations. We're huge fans of MyPy at Dropbox, largely because this is huge if you have a large code base. So we have hundreds of engineers working on this. Being able to know exactly what's going to happen when you call a function is a big deal. And so being able to do that natively in the syntax is just fantastic. Next, generally just syntax improvements, things like f-strings. There's a long list of those, but when you combine them, you get much greater developer productivity. And that's something we wanted to take advantage of. As you might be able to imagine, we use the OS module a lot. So Dropbox's job on Windows, Mac, and Linux is to sync your files. And so we use the OS module, we use POSIX module quite a bit. And there's been so many improvements there, so many enhancements over the years that we really wanted to be able to take advantage of them. Pathlib is the best example of that. And finally, coroutines. So the whole async I/O effort, that's just a great leap for the language. To us, it opens up an entirely new way to think of concurrency. And we see a potentially much better way to implement a bunch of patterns that occur very often in our code. So really, there was no shortage of excitement around Python 3. And for the second part of the reason, Python 2 became an issue. It became difficult to maintain it and to keep it running. we're going to consider Python 2 for Windows as an example. So that's a good example because Windows is our most popular platform. There's been a lot of amazing work done in Python 3 to improve Windows support, but we weren't able to take advantage of that work. If you consider how old the compiler requirements are for Python 2, then you see the sort of core of our issue. Python 2 requires Visual Studio 2008. Let that sink in. That is an 11-year-old compiler, right? And there's a good reason for that. It means if you download something from Pippi, you get a binary that's going to work the same way regardless of where you download it or where you install Python. But that's a bit of a problem. Now, thankfully, we control our own Python, and so we decided to fork Python 2. And we actually manually patched it all the way up to supporting Visual Studio 2013. But the more we did that, the more painful merges were becoming, and the more kind of undocumented behavior started appearing. And this came to a head when some of our key dependencies, like Qt or Chromium, just started requiring the very latest and greatest in compilers. And then on top of all of this, we realized we were starting to spend considerable time taking features from Python 3 and backporting them into 2. So for example, and this is totally true, we actually backported Python 3.2's GIL into 2.7, specifically for the native responsiveness issues that we were seeing. So the point of all this is Python 3 basically became a blocker to a bunch of our initiatives. We realized that in order to build what we wanted to build, we needed to upgrade. And the more we waited, the worse this would get. And to talk about the how, Damien?
Cool. All right, so we knew that we had essentially upgraded Python 3. And this talk is about how we actually did it. So we have a problem at first, right? Which is Dropbox is not a small application. We have like hundreds of thousands of lines of code with hundreds of engineers that push like code every day. We support a large number of configurations. So we don't just run on the server. On client, we like run on Windows, we run on macOS, we like run on Linux, and we support like pretty old OSs. So making sure that our code runs everywhere is not like just super easy. Also, as Max said, we have a custom fork of Python, which means that we have pretty much like essentially decade of patches that we need to kind of try to migrate and maintain and all of that. And finally, the last thing is we like a desktop application, which means that shipping code doesn't just happen overnight. Releasing an app happens every couple of weeks, but we go through like a series of channels, which means that the time it takes between I land the code now, essentially you will be able to run the code that I landed in 6 weeks. So you cannot just flip a switch and change all your stuff to like Python 3 or things like that and just make a switch and everything is available everywhere. So that's a bit essentially of like a sort of complexity and the scope of the issue here. So how would we like even start with that? Because there's not like a perfect time to like just go ahead and oh yeah, let's like go ahead and migrate to Python 3. So where did we begin? And really it really came out of Hack Week. And if you're not sort of familiar with like Hack Week, it's basically we have a couple of weeks a year where like engineers can work on whatever they want and try to do the things that they probably wouldn't either have time or sort of bandwidth to like do in the rest of the year. So in 2015 and 16, like a bunch of us just met and we're like, yeah, what if we just tried? And it was super important to like kind of build like a sort of momentum and getting a lot of folks excited. So there were folks that were excited about like the language itself. There were folks that were excited about like sort of challenge and we met all these folks and we kind of set a little team during Hack Week and we worked on that. And most importantly, we showed the rest of the organization that, hey, this is doable. Like we're all small, we can make it work. That's something that we could do. And basically, yeah, it was really the perfect sort of setting to like start the work and bootstrap it. So as part of Hack Week, we also like got a chance to discover what would work and not work. So like a great example, the first thing that like we tried to say, hey, we got a code base there, let's just feed it into 223, get code, and just like everything is gonna work, right? Well, we figured out it's not that easy, so we kind of looked at, various options and realized that. But what really came out of Hack Week was we put a system in place, like we had a way to start a Python interpreter in Python 3 and feed our code to it. Nothing worked. It was like doing nothing. It was just it crashed like at boot. But at least we sort of unblocked other engineers after Hack Week to worked on it and just iterate and try to make oh yeah, we'll fix a bunch of tests and make sure they run on Python 3 and things like that. So it was super, super important. So that's the graph. That's a histogram of basically a number of, it's not a number of commits. There is basically additions and deletions of code that touch Python 2 and 3 across the years, the last 5 years. And you can see the kind of 2 exploratory attempts in 15 and 16, which is really Hack Week. And then bulk of the work was spent in 2017 when we actually staffed the team and decided we all in into that and we just made the work. And we shipped that in 2018. So all the work that happened in 2018 was mostly fixing bugs and try to stabilize the thing and make sure that everything worked. So yeah, most of the work was really a year, but it was kind of spread into a bunch of initiatives early on. So the thing I really want everyone to kind of take out of that is the transition to Python 3 will force it had to be a gradual process. It didn't happen overnight, and it took a while, and we really iterated on that. So let's start actually a deep dive into how and what we specifically did. And I want to talk about the syntax and the basically hybrid. So we had a project called Hercules, and given that we had to gradually move to Python 3, it basically meant that we had to support both 2 and 3 at the same time. So what did we do? From the future, we just imported Python 3 and everything worked. Not quite. It was not that easy. This would have been great. But it was not that bad, as in there is a rich set of tools that can really help you there. So we've used a bunch of modernized and 223 really selectively, rather than throwing the whole code at it, and to mostly fix the sort of obvious issues. So your syntax has changed, exception, you cannot have a comma here and there, you need as, and things like that. Obvious issues that work on 223. So we fixed that. But for us, really the key was 6. So if you're not familiar with 6, it's essentially a module that lets you import things that will work on 2 and 3 at the same time. That makes sense. So you don't have to write a lot of if clauses, if on Python 3, import that. If on Python 2, import that, and do this other way. So we used a ton of that, and basically our code was we didn't want a code to look a lot worse because of the migration, right? We still wanted to have a code base that looked good, and that was easy to work on once we were on Python 3. So that was super key to us. And finally, we wrote a bunch of small helpers. So in nature, if any of you have used a future.utils sort of functions, is really similar. So it's mostly a deal with strings. And these helpers are hey, when I'm fed a string, just give me a Unicode. If I'm fed a string or Unicode or things like that, just to make sure that you're dealing with the right type of string all over the place. And finally, we used a typing module in MyPy. There is a type annotation called text. That's simply Unicode in Python 2 and stir on Python 3. And we really used that where it made sense. And it was super important for us to have our APIs either to a contract. Hey, I will never be past bytes. I'm dealing with a Unicode string everywhere. So we used that a lot, and that was super, super important. So on types in general, as Max said, we're super fan of MyPy. We use it a lot, and it's really, really, really helpful on a code base that is pretty large, right? And as part of migrating, we have annotated our code quite a lot. We reached a 60% as part of the transition. I think we're a bit above now. And that was just, it was just very important for us to kind of verify the compliance with the new APIs or contract, or making sure that the code was actually correct. And for all these issues where you don't really know what sort of type you're passing and really work across, a sort of runtimes, this was important. We even found a bunch of bugs that were just in Python 2 bugs that we've had forever. And that's the classic engineer thing. You stare at your screen and you're like, how did that ever work? And so we found these bugs, and that was cool. However, there's one little thing you won't be surprised. Is strings is just not that easy. And even if you type your code super, super well, ideally you would say, yeah, so stir become bytes, and now your Unicode is stir, and everything is good. But the problem is really Python 2 is very permissive with strings, more than happy to sort of coerce them and things like that. So in order to kind of explain that, I want to go in detail in a couple of little bugs that we've had that just show you what we mean by that, right? So we've all done that. That's basically an authorization header that you want to send through HTTP, and you pass, and you generate a token from a value that you had, and you base64 and put it in there. You run the code on Python 2, and things are yeah, that's good. That's what I expect. Nice. You run the same code on Python 3, and suddenly you're wait, that's not what I want. And you go through your server logs, and why can't I authorize everyone? And the problem is, well, this is not a token. That looks like a representation of a token. So what's the issue here, really? We're trying to interpolate a byte string into a Unicode string. The essential person test is okay, I need to get a string a string representation of that thing, so let me just call stir on it. In Python 2, a byte string is a string. That's what it is. So it just gives that one back, and that goes into there. In Python 3, however, a byte string is not a string anymore. And thus, it needs to call a repr to get a string out of that. And the representation of a byte string happened to contain this a prefix and quotes. So this was a fun one. And a second one that we so this is more of a kind of a scarier bug, I would say. So when you deal with Python versions, there is the code, but there's also anything around the code that you might write a disk or get from a server that might be different across the versions of Python you get. So in that case, that's a simple little thing. You got a database with a table that basically has a bunch of hash and size. And the idea is you want to know the size of a file, and you compute the hash of the file, and you get its size. That's simple. On Python 2, you will just you compute the hash of the file, you put its size, and you just insert that in SQLite. And then back on Python 3, you execute a query where you basically bind the hash and hope to get the size back. But unfortunately, if you run that code on Python 3, you will get nothing. And the reason for that is, well, as we saw earlier, in Python 2, bytes, string, it's a string. So what happened with the third line is basically SQLite is just trying to insert a stir. So we insert a row as text. On Python 3, it says, oh yeah, I'm giving bytes, so that's a blob. So let me just bind it as blob. So it binds in the statement as a blob, and basically the query doesn't match anything because there is no blob that match that. So this was a fun one. So that's kind of issues with strings in general, a lot of little things. So now that we can actually write code that works in Python 2 and 3, how do we make this sort of lasting improvements and making sure that code works and we avoid a bunch of regressions? So what we did is we made sure that our tests always run in Python 2 and in Python 3. And we made sure that we type checked on Python 2 and 3 all the time. And basically, we made it hey, if you break a Python 3, you break the build entirely. And that's just breaking the build, and that's not acceptable. And better yet, we even set a Git hook, that would just run all unit tests on Python 2 and 3 and MyPy on Python 2 and 3. And you couldn't push any code unless it worked on both. And yeah, so basically we were preventing anyone from writing code that wouldn't work on either. So we really try to make it easy for our engineers to write code that would work on Python 2 and 3 from a day one. And yeah, and that was quite important for us. So I'm gonna give the mic back to Max to talk about the runtime.
OK, so let's go into the second part of our deep dive. So now that our code's compatible with Python 2 and Python 3, how do we get it to our users? So let's take a step back for a second. So if you're using Python from the client side, that means you're actually shipping 3 things. One, you need to ship a native app that's compliant with the platform's app model. Now, that's a complicated way of saying that on Windows, you need to ship a .exe, and on Mac, you need to ship a .app. Second, you need to ship a Python interpreter, so something to run Python with your app. And then third, you need to compile your Python source code to bytecode, and then you need to ship that too. So we view our app as being this sort of Russian doll of all of these three things. Now, on desktop, this is usually done by popular tools called freezers. Shout out to PyInstaller or Py2App. Those are the ones we've used before. Now, as part of this project, though, so we used freezers for a decade, but we actually decided not to do that anymore. We call this project antifreeze, haha. So why would we want to do this, right? Well, first, in the beginning, Python 3 support was not actually very widespread in the freezer tool. So PyInstaller at the time didn't support it, though it does now, shout out. Second, we actually rely quite a bit on native toolchains now. So as you can imagine, Dropbox integrates pretty deeply with each operating system. And if you take Mac as an example, there's some features now on macOS that require you to use Xcode to take advantage of them. But since the freezers hide all of that from you, it can become difficult to tap into those features. And for some of those features, they were very important to us. And finally, Python's not alone in our code base anymore. So where the first version of Dropbox was just Python, we now have a whole bunch of Objective-C and Rust and C and C++. And since freezers are very deeply embedded in the Python environment, they're basically setup tools. And setup tools isn't quite good enough as a build system to wrangle all of these things together. So to us, it was just more advantageous to control our native entry points. Shout out to PyInstaller. We think it's really good. It's just that Dropbox kind of became too complex for that. The way we actually implemented this is we just use the C API directly. So even there, actually, Python 3 made improvements and provided generally better isolation from other Pythons installed in the system. Like PySetPath comes to mind. So back to our problem. So we want to be able to get Python 3 in the hands of our users, but we need to do this gradually. We can't just turn it on for everybody at once, because there would be a whole bunch of bugs and people would be angry. So how do we do this? Well, we need to enable Python 3 for very specific groups of users. And how do we do that? Well, now that we control the main function, now that we control the entry points, we can actually do whatever we want. We can now ship more than one Python runtime. And that's exactly what we did. We actually shipped two. So we had a Python 2 runtime and Python 2 bytecode, and a Python 3 runtime with Python 3 bytecode. And then what we would do is we would choose at runtime which one to use. And we call this project Hydra, haha, because multiple snakeheads. So the point here is that to get the granularity that we needed and to target very specific user populations, we needed to ship a hybrid application. It wasn't good enough to just have hybrid source. So let's look at the last step. So how do we, all the pieces are into place, how do we bring it all together and actually complete the transition? So there will be bugs. We fully expected there to be bugs that we didn't know about and that we would discover halfway. But we needed a process to deal with them. Now, we can actually give selectively Python 3 to some of our users. We need clear criteria to grow that population. So we can't just, how do we add more people to that group? And we knew that we needed one capability, and that's to recover very gracefully if Python 3 breaks. So in a way, we'd want to be able to try Python 3, and then if something breaks, bail out. And that actually means that you need to be able to move back and forth between Python 2 and Python 3 seamlessly. And that's important because of what Damien said earlier, especially when you persist data locally, you need to make sure that you're writing and reading consistently on both versions of the language. Otherwise, you'll corrupt the state. So how do we do this? We designed a fail-safe initialization process. So basically, we'd always start out in Python 2. And if we would check in with our servers, and then we'd say, hey, am I allowed to run Python 3? No, yes. If so, we would restart ourselves in Python 3 mode. And that actually was implemented through a command line flag. So you would launch literally dropbox.exe/py3. That was the flag. And then if an app crash would happen, because the normal initialization is without any arguments, you would always just restart in Py2. So the default was always Python 2, and that ensured that users never remained in a broken state. We also had a logic to detect if we crashed repeatedly and then just stop trying for a little while. OK, so now that we can introduce new users, that we feel relatively confident about that, how do we actually release? So we decided to do that in 3 stages. And those roughly matched how we released Dropbox itself. We would start with something we call internal alpha, and that's for Dropbox employees. So we basically ate our own dog food. Then we would move on to the beta stage. And the beta stage is for users who explicitly signed up for bleeding edge, and they're generally okay with a little bit more instability. And finally, we'd go to stable, and stable is just the entire population of all Dropbox users. And what we'd do is we'd slowly kind of move the dial within each stage, and we would never move from one stage to the next unless every last Python 3 bug or crash or exception was investigated and marked as being green. This was very conservative, and it actually took us 9 months to fully roll this out. Because remember, every commit takes 6 weeks to make it to a user. So let's take a look at how the rollout actually worked. I don't know if you can see this well, but green represents the Python 2 population, orange represents Python 3, and then we moved in increments of 10%. The longer pauses show places where we had tougher bugs that took a longer time to investigate, but we would never grow the population until the bug was resolved. And we never went to 100%. Can anyone actually tell me why we never went to 100% here? Want to hazard a guess? That's good. No, so the actual reason is we didn't want to regress Python 2. So this whole time we were paranoid, and we were thinking, what if just this like a catastrophe and it goes horribly wrong, and we want to just undo all of this tomorrow? The worst thing we could do is send everyone to Python 3 and then regress Python 2, because then we wouldn't be able to go back. And so we always kept at least 10% at each stage running Python 2 just to be sure. And this is a stable rollout. This one is a bit more abrupt. And what we did is we initially went to 10%, gave it a bunch of time, looked out for all of our metrics, all of our exceptions, and when no bugs appeared, we then made a release that removed Hydra and only shipped Python 3. And then we were basically done. So this conservative approach basically meant that the vast majority of migration bugs were actually found in the first stage. In fact, there was one bug we found afterward, and that was where we briefly broke proxy support, but that was fixed really quickly. So dogfooding works. Now, in conclusion, so all of this to say that client software can be unique here. We think we succeeded because we gave ourselves complete flexibility to migrate users, because we made it really easy for developers to join in. We made it hard to actually regress the winnings that we'd get. And we very conservatively transitioned, and we never left any stone unturned. In fact, exclusive, we just moved from Python 3.5 to 3.7, and it took one engineer 2 weeks to do so. Many of the processes we actually came up with are still in place today. And with that, we'll open it up for questions. Thank you. All right. So I'm told we can do 2 questions. So anyone want to hazard a question for us? Hi.
Hello. So how many people internally test your software as if they were clients? I mean, because you said you got all the bugs internally.
Yeah.
So the problem we have is that internal users in our company do not use our software as clients, right?
Right.
We use like a very minimal fraction of what the software offers. So did you just cut bugs internally because it was just bugs from startup, or was it because they were actually users just trying to their job QA or testing?
So we're lucky in that way. So the question was, how do we detect bugs internally? Like, did the population at Dropbox actually use the software? And the answer is yes. So all Dropboxers run the desktop client. It's kind of pre-installed on all of our machines. And so the population was really good. And yet, we were lucky in that way, in that everyone used the product, and so we were able to get most of the bugs that way.
Yeah, also, yeah, it's working. Yeah. So the other thing is like, is Dropboxers at Dropbox, but they also get the same build at home. Yeah. So for example, that's how we got like a lot of Windows issues. So most folks use like Mac at work, like, things like that. And we have a lot of very old Windows machine at home so that's how we caught a bunch actually of these issues. It's like at home.
Okay, I think you were in line, yeah.
So you said you had a lot of issues when you were working in Pi 2, which caused you to migrate to Pi 3. Why did you did you decide to move to Pi 3 before checking out other Pi 2 interpreters like PyPy?
Oh, that's a good question. I think it was less about, so the language features did play into it, but it was primarily a compiler thing. And so I wasn't extremely aware I'm not super aware of PyPys or the other sort of compilers, toolchains, and those requirements of other interpreters. But we had used CPython for so long, and we relied on it so deeply. We had made a bunch of changes to it that it didn't seem it seemed like it would be another extra step of migration to try another interpreter, and we weren't sure whether we could sort of maintain the same sort of compiler tool chains as before. But that's a good question. I don't know that we very deeply explored that option, but we kind of assumed that we wanted to keep using CPython.
Cool.
All right.
And
Thank
we
you
can
very
talk
much. We can
afterwards, I
catch
guess.
up. I'm
Yeah.
sorry.
We'll do
I
it
think we have to
offline.
run, but thank you. All right.
Thank you.